Good afternoon. Today we're going to convert an ODB file of a two-layer board into SolidWorks. You can see right now what the ODB looks like. It's a board with some curves in the side, top metal. There's some bottom metal also. There's components on the top and on the bottom. There's also a silk screen and there's a solder mask. So let's convert this. We're going to use Artworks NETEX-G program. We'll start in the preference section. We'll create a couple of directories to hold our files, working and output. And that's all we need to change right now. Now we'll go to File and we'll import the ODB. And we'll select the ODB we want to import. It'll be scanned. And once it's scanned, it'll show us what layers are available. Now I want to add the silk screen and the solder mask to these other layers. You can see we're getting the signal layers, we're getting the solder mask, the components, and the drills. So we'll just click import. Alright, our data's in. Now we're going to do some setup. Let's start by defining some other files. SST is our top silk screen. SPT, we're going to call that a pass-through. SMT is our top solder mask, and that's a reversal, so make sure you check the reversal, as is the bottom solder mask. Let's look at our drills. Now, we really don't want to see the vias in the output, so we're going to drop any vias. We're going to pass all the mounting holes that are bigger than 50 mils. Okay. For the output, we're going to use the 3DI for step. That'll be the name of our output file. If we want our bodies, which we do, we'll select Create Dielectric Bodies. And we want the profile to be auto. It'll pick that up from the ODB profile. If we check our properties, we'll see that the various layers have already been imported and we have picked up some widths from them. I'm going to accept these values here. So now there's nothing left to do but to click Execute. So this will take maybe 10 to 20 seconds. Alright, we're finished. There's a log file which tells us about the conversion, but we don't really need to look into that. Now let's look at the output using the 3D view program. Here's our board. You can see all the holes that were bigger than the 50 mils we specified are treated as drill holes. We're looking at the top solder mask. There's not much to see. And here's the bottom side. Let's turn off the solder mask and look at the metal. You can see our top metal and you can see our bottom metal. I've noticed something is not entirely correct with this text. It wasn't assigned any width in ODB, which is a mistake. The text may not come out correctly in 3D. So what we're going to do now is we're going to import this into SolidWorks, so we now have a 3D model. Now we're going to load the data into SolidWorks using the Read 3DI plugin. So we'll select our file. This is the file we just created. The only settings we need to worry about is where we want the output to go. So now we'll click Import. The import process will take a while, and the time it takes depends on how many solid bodies per layer it has to generate. So this first layer, M1, has a lot of solid bodies. This will take several minutes, so we'll pause until this process is done. Alright, we can see that in SolidWorks it produced the two parts, one for the top and bottom metal, one for the dielectric, the two solder masks, the silk screen, and the components. So let's turn some of these off. Let's turn off the top solder mask, and now we can see the metal and the substrate. Let's turn off the top components also, and now let's rotate the board over to the bottom. Turn off the bottom solder mask, and now we can see the metal and the components there also. So everything on this board is a 3D solid body. The only things that have gone wrong is this text. And this was apparently drawn incorrectly in the ODB file, and that's why the text has come in like that. But in terms of 3D model, it's a very nice 3D model. You can put it into some kind of a package. You can use it for documentation. You have pretty much everything you need to do 3D operations on it. Thank you.